Hello students, welcome back to my channel. How are you doing, all of you? I hope you are doing well. I am creating this video in continuation with the other videos. You can search for other videos, okay, in continuation with this. So we are discussing 2022 NEET questions. So coming to question number 28, the dimensions, this belongs to the quantity. Now here students, we have to apply a small trick. Otherwise, what is the general method to solve these kind of questions? You are supposed to find the dimensional formulas of each of these four. One by one you have to find and you have to check whether it matches with the given dimension formula or not. So that could be a time consuming process. So here what we have to see, we have to use a little bit of observation, and observation shows that mLT power minus 2 stands for force and A stands for current. So upon A square means upon I square or upon I1, I2. So this quantity must represent some force upon I1, I2. So based on this, we can think of a formula. If you recall, if you have two parallel wires, long parallel wires, separated by a distance d and carrying currents I1 and I2, Ampere's law of parallel currents. Ampere's law of parallel currents states that the force per unit length of either wire is equal to mu 0 by 2 pi into I1 I2 upon distance between them. So now dimensionally what will happen? Dimensionally it will get cancelled and 2 pi has no dimensions. So F upon I1 I2 is basically mu naught, and mu naught stands for magnetic permeability. So first option is the correct option. This is how you find it. Moving to the next question, question number 29. Given below are two statements. You can see one is Biot-Savart's law gives us the expression for the magnetic field strength of an infinitesimal current element of a current carrying conductor only. This is true, students, because it gives the magnetic field strength of an infinitesimal current element dl of a current carrying wire. Yes, it is true, because suppose you have a small current carrying wire, say IDL, okay, and if you choose a point P at a distance r, let us say this angle is theta, then the magnetic field here is given by mu 0 by 4 pi. Numerically it is I dl sine theta divided by r square. This is Biot-Savart's law. So statement 1 is correct. Now statement 2 says Biot-Savart's law is analogous to Coulomb's inverse square law of charge q, with the former being related to the field produced by a scalar source ideal, while the latter being produced by a vector source q. This is wrong, students, because as you know, charge is not a vector. Charge is a scalar quantity. Moreover, this current element is a vector quantity, because actually we write current element like this. Current element is always written like this, and the direction of this current element is in the direction of current. As you all know, current always has a direction. So the direction of current element is in the direction of current. So both these things given are wrong. So this is incorrect. So statement 1 is correct, 2 is incorrect. So statement 1 is correct, 2 is I'm sorry. Statement 1 is correct and statement 2 is incorrect. First option should be the correct option. Then moving on to the next question. Question number 30. A long solenoid of radius 1 mm has 100 turns per mm. If 1 ampere current flows in the solenoid, the magnetic field strength at the center of the solenoid. Now we all know that the magnetic field at the center of a solenoid, assuming it to be idle, is actually mu 0 Ni, isn't it? B is given by mu 0 Ni, where N is the number of turns per unit length. So if you have total number of turns, divide by L to get number of turns per unit length. So it's a matter of formula substitution. So let us substitute the values. Mu 0 is 4 pi into 10 power minus 7. Total number of turns is 100. So 10 power 2. And length is Sorry, they have given small n as per mm. So length is millimeter per millimeter. So 10 power minus 3, and current is how much? Current is 1 ampere. Okay, so it has nothing to do with the radius, so we don't require radius as such. So this will be 4 into pi. Pi is 3 point something. Let us see the powers of 10 here. Minus 3 goes up, becomes plus 3. So 2 minus 2 plus 3 is 5. Minus 7 plus 5 is minus 2. So this will be 12 point something. So 12 point something into 10 power minus 2. Fourth option, Tesla. Moving on to the next question. A square loop of side 1 meter and resistance this much is placed in a magnetic field of this much Tesla. If the plane of loop is perpendicular to the direction of magnetic field, the flux through the loop. It's very elementary question, basically. So here you see the flux, magnetic flux linked with the coil is N A B into cos 0. Why cos 0? Because the area vector of the loop and the magnetic field both are in the same direction. In other words, angle between them is 0. So cos 0 will be 1. So that's the reason I have taken NAB. So what number of turns, unless otherwise mentioned, we'll assume it to be 1. 1. Then area, being a square loop of side 1 meter, area will be 1 into 1, 1 square. Coming to magnetic field, it is half Tesla. So half. So finally, you have only 0.5 Weber. So fourth option is the correct option. Moving on to the next question, that is question 32. The peak voltage of the AC source is equal to. This is very simple, students. You all know that IRMS is equal to peak value. Sorry, voltage. They are asking about voltage. Not a problem. So RMS voltage is equal to 1 by root 2 times the peak voltage. So peak voltage will be root 2 times the RMS voltage. So root 2 times the RMS voltage. So I'm sorry students, this should be root 2 actually. So first option. Okay. I'm sorry. The the correct. The peak voltage is this much, correct. Moving to the next question. From Ampere's circuit law for a long straight wire of circular cross section carrying a steady current, the variation of magnetic field in the inside and outside region. Now, if you know the applications of Ampere's circuit law, you will find this one of the applications of Ampere's circuit law. The variation of magnetic field across the cross section of a cylindrical current carrying wire. Okay. Suppose this is the cylindrical cross section. This is the cylindrical cross section. Okay, long, and it is carrying a uniform current. It is uniformly carrying a current. Then okay, variation of magnetic field. So inside at a distance r, okay, the variation is like this, whereas outside you can apply the same formula as usual. Formula is mu 0 by 2 pi due to an infinitely long wire, total current upon r. So here outside it is, you can see b varies inversely as r. It is a rectangular hyperbola. Okay, inverse variation corresponds to rectangular hyperbola, and this is a linear variation corresponding to a straight line, because here b will be proportional to r. R is the distance from the center. So so the variation of field is a linearly increasing function of distance r up to the boundary. So first option is the correct option. Then moving on to the next question, a big circular coil of 1000 turns and average radius this is rotating about its horizontal diameter, and vertical component of Earth's magnetic field is this much. So magnetic field is, electrical resistance is this, the maximum EMF induced in the coil. So this is the coil. Okay, it is rotating about a horizontal diameter. It's rotating like this, whereas the field lines are like this. Magnetic field lines, earth's magnetic field, vertical component of earth's magnetic field, it is like this. So at any instant, if I take the area vector as a, angle between magnetic field and area vector as theta, then flux due to magnetic field is n a b cos theta. Remember, d theta by dt is omega. So induced EMF is minus d phi b by dt, which is minus NAB into derivative of cos theta is minus sin theta d theta by dt. Remember, we are differentiating with respect to time t, and d theta by dt is omega. Okay. So the maximum EMF induced will be this much, corresponding to sin theta equal to 1. So the maximum induced EMF will be omega NAB. Omega is 2 pi f. No, omega is given, I think, straight away 2 radian per second is the omega. So 2 radian per second. Number of turns is 1000 given. You can see number of turns is 1000. Area. Average radius is 10 meters. So basically, area will be pi r square. And magnetic field strength is 2 into 10 power minus 5. So 2 into 10 to the power minus 5. Now you can see 10 power 3 and 2 is 10 power 5, which gets cancelled with 10 power minus 5. We are left with 2 to the 4, 4 into 3.14. This is induced current. So induced current will be divided by resistance. Not a problem, student. So immediately we can find this. So maximum induced current will be maximum induced EMF divided by resistance. So this is 4 into 3.14. So 12 point something divided by 12.56. So it is 1. So first option is the correct option. Moving on to the next question, that is question 35. A series LCR circuit with inductance 10 Henry, capacitance this much, resistance this much is connected to an AC source of voltage this. If the resonant frequency of LCR is nu naught and the frequency of the AC source is nu, then. And now we all know that the frequency is given by coefficient of t. Angular frequency is given by the coefficient of t. So omega is basically 100, and we all know omega is 2 pi into frequency. So what is the frequency then? Frequency is 50 upon pi hertz, because 250s and this pi goes below this. So 50 by pi is nu. That is clear, students. Now coming to the resonant frequency. Okay. So resonant frequency, we know that the state of resonance, in the state of resonance, the net reactance is 0. In other words, the inductive reactance is same as capacitive reactance. So inductive reactance in the state of resonance is this, whereas capacitive reactance in the state of resonance is this. So accordingly, we have omega naught as 1 by under root LC, and rewriting omega naught as 2 pi nu naught, we can write nu naught as 1 by 2 pi under root LC. So it's a matter of substituting the values. What is L and C? Let us see. L is 10 and C is 10 micro. So L is 10 and C is 10 micro. Micro stands for 10 power minus 6. So here you have 10 power 2 and 10 power minus 6. So 10 power minus 4, which goes up becomes 10 power plus 4, but there is a square root. So it will become 10 power 2. Okay. So 250 is 100. So 50 by pi. Even the resonant frequency is also the same. So correct option is the fourth option. Moving on to the next question. That's all students in this. Thank you so much for watching my video. Kindly subscribe to my channel and hit the like button. Thank you.